Hello, my curious physicists. Let me begin with something you've surely seen. Ever looked into a dressing room with mirrors on two sides? Suddenly, you're not just one person anymore, you're an entire cricket team of reflections staring back at you. Here's why: when two mirrors are inclined at some angle, which we call theta, each mirror bounces light back and forth, and each image formed by one mirror becomes the object for the other. It's like mirrors playing a never-ending ping-pong match with light. And geometrically, all these images, along with the real object, lie neatly on the circumference of a circle. The center of this circle is the intersection point of the two mirrors, and the radius is simply the distance of the object from that point. Isn't that just beautiful symmetry in action? Alright, now you must be wondering, exactly how many copies of me will the mirrors make? Physics gives us the magic formula. Number of images, n, equals 360 degrees divided by theta. I'll say it clearly, n equals 360 divided by theta. This works because each reflection effectively rotates the object around the mirror intersection by an angle theta. To make a complete circle of 360 degrees, the number of possible reflections is 360 divided by theta. The smaller the angle, the bigger the crowd of images. So, yes, narrow mirrors make you an instant celebrity with more reflections than you bargained for. Now here comes the twist. It's not always exactly n images. It depends on whether n is odd or even, and where the object is placed. Case 1. If n is odd and the object is placed asymmetrically, you'll get all n images. But if the object is placed symmetrically, that is, on the bisector, then one pair of images overlaps, so the total becomes n-1. Case 2. If n is even, no matter where you put the object, the number of images will always be n-1. So symmetry is like a referee, it decides whether some images merge together or not. And that's why sometimes your reflection team loses a member. Let's check out some cool special angles. First, parallel mirrors, that means theta equals 0 degrees. Plug into the formula, n equals 360 divided by 0. And since you can't divide by 0, we treat it as infinity images. And indeed, if you've stood between parallel mirrors, you've seen an endless tunnel of reflections going off to infinity. Now for perpendicular mirrors, that's theta equals 90 degrees. N equals 360 divided by 90, which equals 4. Since 4 is even, the actual number of images is n-1, which is 3. And yes, if you stand in a corner with two perpendicular mirrors, you'll always see 3 reflections of yourself. So, infinite for parallel, 3 for perpendicular, easy numbers to keep in your exam toolkit. Let's put the formula to work with a numerical example. Say the angle between two mirrors is 72 degrees. Then n equals 360 divided by 72, which equals 5. Now, since 5 is odd, if the object is placed asymmetrically, number of images is 5. If the object is placed symmetrically, right on the bisector, then one image overlaps, giving n-1, which is 4. So the same setup can give you either 5 or 4 images, depending on where you stand. It's like physics saying, stand off center and you get a bonus reflection. But wait, there's one more elegant detail. All the images formed lie on a circle. The center of this circle is the intersection point of the two mirrors. And the radius, that's simply the perpendicular distance from the object to that intersection point. So when you draw these ray diagrams, don't just scatter images randomly, plot them equally spaced on a circle. It's like placing chairs around a round dining table, each reflection gets its perfect seat. So, to wrap it all up, Images formed by two inclined mirrors follow one neat recipe. Step 1. Compute n equals 360 divided by theta. Step 2. Check odd or even. Step 3. Adjust by symmetry. And voila, you know exactly how many copies of yourself the mirrors will generate. Parallel mirrors make infinite images, perpendicular mirrors make 3, and everything in between follows the odd-even rules. This concept isn't just for fun mirrors, it's what makes kaleidoscopes magical, periscopes functional, and optical illusions fascinating. So the next time you're surrounded by multiple versions of yourself, don't freak out, it's not time travel, it's just physics with mirrors. I hope this clears things up and puts a smile on your reflection. Until our next session, keep exploring, keep asking questions, and remember, your reflection is always keeping an eye on you.